Again, this is Progress' own development. So I'd like to invite Victor Lavrov to tell us how you can use imagery from AIST-2D to feed your mapping purposes. Good afternoon. If you are a frequenter to Rakurs conferences, you may know that traditionally Innoter does photogrammetric research of different Russian satellites. Previously, I reported on Canopus V, Resource P1, Resource P2, Belarusian satellite, some foreign satellites. So today I'd like to tell you about a joint initiative. I'd like to thank, by the way, the staff and the administration of Progress company. We signed a memorandum of understanding with each other. This is now historic. AIST-2D satellite was launched from Vostochny Cosmodrome as part of a cluster launch during its maiden launch on April 28, 2016. The main characteristics. I think you as photogrammetrists will be aware that it operates at the altitude of 450 kilometers. It's a geosynchronous orbit. The resolution is no worse than 1.6. I'll go back to it. In panchromatic mode, that is. We'll have to validate it further. In multispectral band, at least 4.5, and infrared, at least 122. There is a pilot radar SAR complex with 5-meter resolution. Swath width is 39 kilometers. At least for the band that we provided photogrammetric verifications on. I'd like to make a reservation, though, that this is an experimental satellite. D in the name AIST-2D stands from demonstration. And since it was launched at our own expense, I mean at the expense of Progress company, the purpose was to see how dedicated equipment could work and to test out processes for future developments for satellites that will be produced at a larger mass scale. We conducted about 100 tests in different regions using different techniques. These are the main algorithms that we applied: RPC, 1 and GCP, 4 GCPs with various accuracies. I'm not going to enumerate all of that. You can read it out for yourself. This is the main algorithm that we used.
What else can I tell? A few areas that I'm going to show you here. We tried to use them for the accuracy of the experiment. Also for those areas where we can acquire highly accurate checkpoints. And that's why in our program we had ground control points. The GCPs in this table are of different accuracy and precision. That's why we acquired different results. When processing the town or the city of Columbia in the United States, the RMS error was 4 to 5 meters. Also, we experimented when using oblique images of different angles. Here you can see the Newcastle area, and the accuracy of GCPs, or checkpoints, is getting worse. Philadelphia, Hogwarts, Australia, many photogrammetrists use this testing ground because it is equipped with highly precise coordinates of GCPs. So you can see the accuracy of GCPs is 0.2 meters in plane and 0.3 meters in height, and you can see what can be achieved with the use of these GCPs. It's pixel precision with RMS of 1.6 meters, which is exactly the size of 1 pixel. And one thing I wanted to tell you, I promised that I will return back to that. The size of pixel is lying within this range. Там сейчас убирают квартиру. Только что зашла. And the difference is 1.6 meters here. Also, we had a study that's a small satellite. Technologically, we organized an experiment on building the model on the orbit overlap. That was the May and June 1st image acquisition. We acquired the result, and I know that the CMZ people did similar research with Canopus, where they don't have stereoscopic image acquisition possibility, but they can use these results instead. In fact, if you look at the results in height, I will explain why they're here in this way. 21 meter here. The main conclusion for the experimental satellite AIST-2D showed very commendable results, which means that it can be practically used. Like, for instance, if we have highly accurate ground control points, then we have enough data for 1 to 5,000 scale, and also it can be used for update of the maps of 1 to 25,000. And algorithms of AIST-2D are improving with time, and we see that their initial results after launch in 2016 and now are much better. The accuracy has been increased by 100% actually. Some examples. This is Sochi. This is Mexico. This is where we are at the moment. And we acquired images very quickly, and which means that the working program on planning and acquisition of data works very well, just like originally designed. And in 3 days we can do requests in case of good weather conditions. This is the area where our hotel is acquired by AIST-2D. In fact, that's all I wanted to tell you about my presentation. As for our immediate plans and future plans, now we are putting into our program future areas. We discussed it with Valery recently, just 2 weeks ago, right? Roscosmos gave us the right to RKS Progress to commercially use the data acquired by AIST-2D. So within the framework of preparation for these activities, we are considering some of the promising areas for acquisition. So I'm addressing now specialists here. If you're interested in the data with these specs, approach us, please. We are going to acquire these images for the future. Whenever we resolve the problem with commercial applications, then we'll start providing you this data from our archive. At this conference, we already discussed it with our colleagues from Rakurs, and it's good that in the range of compatible satellites, we would be good if they had AIST-2D. Of course, it will be made compatible for photomod. We'll also work on integration with the other leading photogrammetric software, so they're compatible with the data from our satellite. That's it. Thank you very much. Thank you, Victor. Dear colleagues, any questions? While colleagues are thinking, maybe I have a question for you. Maybe RKC Progress can tell us about future plans of the AIST spacecraft. Are you going to produce new generations, or that's all you're going to have? I will tell you about what I know. Maybe I know less than my colleagues. Then they will add something based on the plans that I've heard about. Indeed, ideally, it is planned as a series of small satellites. But now it's difficult times for Russia. All of us feel it. Everything is limited by financial constraints. I understand. And demo materials can be acquired in somewhere on the webpage from your company or RKC Progress. On the webpage of RKC Progress, you can find a lot of samples. They're updated every month. I think they start to upload pictures in June, and then every month they post different regions, different samples, and the data with metadata can be ordered from us, and we'll get it from partners. Some colleagues wanted to add something. Yes, RKC Progress, I have some things to add here. As far as the subsequent development of AIST-2D is concerned, now in RKC Progress we are working on 3 different options of subsequent development of this system. Number 1 is we'll have an additional platform based on the operational experiments that we do. The first option, our linear resolution will reach 1 meter or better. Second option, we'll have an equipment for stereo with 2 lenses at an angle with each other. A third option is 2 cameras mounted parallel to each other for a broader swath. The technical designs will be prepared by the end of the year, and then customers or investors are invited to implement this project. Okay, thank you very much. Then investors are invited to look at this project. Sergei Serebryakov, next. We've raised this issue a number of times. Our facilitator spoke about the mandatory certification. And I want to ask you whether this methodology can be considered as an element of possible elements of certification. And the second question, why? These are always different territories. Why don't you do it in our area? Thank you for your question, because it's also a reminder for me. I didn't mention it, but in our future experiments plan, we're going to acquire Polygorsk testing ground, which used to be testing ground for Canopus and Resource, and also we'll discuss with Professor Chebunichev to acquire another testing ground. So, and as far as foreign areas are concerned, like United States, once every 4 years they do popular census, and they do acquisitions, which is then provided for free. So it's a great opportunity to get high quality data for free. As far as certification is concerned, it would largely depend on how it will be reflected in the normative documents, but I believe that such studies must be done. How else can we confirm the accuracy? Maybe some other characteristics will be confirmed. There are radiometric properties and other things, but photogrammetric quality must be confirmed like this. Okay, I would like to add one thing about the testing grounds. You don't need to go to the Professor Chebunichev. Roscosmos has its own satellite observations system, which consists of testing grounds, including Zalutsk and Petigorsk testing ground, and 2 more radar testing grounds. All the colleagues are invited to understand that in Russia we have such a system to calibrate all the satellites, and foreign partners are welcome to do it also jointly with our Chinese and Indian friends. We exchange and share data on the calibration testing grounds. Anybody else would like to ask a question? Thank you very much then for a very interesting presentation.